The purpose of the Air Data Inertial Reference System ADIRS is to provide air data and inertial information to the EFIS system, the FMGC, and other users.
The A330 A340 has 3 separate, but identical, air data inertial reference units.
Each ADIRS combines an Air Data Reference Computer, or ADR, and a Laser Gyro Inertial Reference System, or IR. The ADR and IR systems of each ADIRS operate independently, and failure of one system will not cause failure of the other. The ADR part receives information from aircraft probes and sensors. The ADR part provides various items of air data to the Flight Management and Guidance Computers, FMGC, and other users. The air data provided includes Mach, airspeed, temperature, overspeed warnings, barometric altitude, and angle of attack. The IR part provides inertial data to the FMGC, EFIS, and other users. The inertial data provided includes track, heading, acceleration, flight path vector, aircraft position, ground speed, and attitude. The 3 ADIRS are controlled through the ADIRS panel, located on the overhead panel.
They are initialized through the 3 MCDUs located on the pedestal.
And by 2 of the switches on the switching panel located at the front of the pedestal. Independent data is supplied by each ADIRS. Let's see an example of this. In the EFIS system, ADIRS 1 supplies the captain's EFIS and ADIRS 2 supplies the first officer's EFIS. ADIRS 3 is available as a backup to either EFIS system via the switching panel.
Now, let's look at the Mode Selector Unit panel, MSU.
The panel is divided into 2 parts, the upper section for the IR and the lower section for the ADR. The 3 rotary mode selectors have control over both the IR and the ADR. The controls and indicators for the individual ADIRS are grouped and arranged in the following order: 1, 3, and 2.
Each ADIRS has an associated IRS rotary mode selector. In the off position, the ADIRS is not energized, so ADR and IR data is not available. The 3 ADR and 3 IR switches normally remain on, but they can be selected off in response to ECAM procedures.
In the nav position, the ADIRS are energized. The nav position is the normal mode of operation and full inertial data is provided to the aircraft systems.
The on-bat light comes on to inform the crew that the ADIRS system is being powered by aircraft batteries only. The light also comes on for a few seconds at the beginning of a full alignment as a test of the battery circuit. Present position information for ADIRS alignment is normally entered via the init page of the MCDU. This method will be explained later. The following items can also be used in case of given failures. The ATT position of the ADIRS selectors allows the selection of this IR mode, providing only heading and attitude information. In case of loss of navigation capability, the 3 ADR switches normally remain on, but they can be selected off in response to ECAM procedures. When done, it only stops the ADRs, not the IRs. The 3 IR switches operate in the same way for the IRs. In case of unreliable airspeed indications, for example after the 3 ADRS failure, the backup speed and the altitude indication are available on both PFDs, provided the 3 ADRS have been set to off. The speed scale is replaced by a backup speed scale, bus, based on the aircraft's angle of attack AOA information and on the slat flap configuration from SFCC. The backup altitude scale is based on GPS altitude information. Due to the GPS altitude inaccuracy, the last 2 digits are double-dashed. The vertical speed indication is not available. The backup speed scale, bus, behaves like a normal speed scale. High speeds, fast, towards the top. Low speeds, slow, towards the bottom. 2 different images can be displayed. One for clean configuration, another one for high lift configuration. Refer to the end of the presentation. The scale is divided in 5 colored ranges. A red upper area above Vmax with decreased load margin, an amber red upper area between Vmax with decreased load margin and Vmax with normal load margin. The green area is in accordance with the normal speed range between VLS and Vmax. An amber red lower area between VLS and VSW, and a red lower area which indicates the stall speed area. The aircraft AOA speed must remain in the green area. For each configuration, a fixed green bug indicates the target speed, which is the optimum speed that the flight crew must maintain, especially during approach and landing. The target speed is automatically set by the system. The aircraft current speed is indicated by a fixed yellow horizontal bar with a yellow triangle. The backup speed scale is designed for a load factor of 1. Therefore, roll maneuvers must be flown with care. Bus operation, fly the green. The following video is a computer animation showing bus operation for a generic Airbus flight-by-wire aircraft. Note: flight parameters are based on an A330 203 GE GW 180 ton. The goal is to present the bus display through different configurations. The aircraft is flown with the bus displayed on the PFD. Auto thrust is off. Alternate law is in force until landing gear down, then direct law. The ISIS speed scale is represented for information. To start with, the aircraft is stable at target speed. Then, an acceleration is performed, in order to reach the high-speed amber-green limit for a short time. The pilot then decelerates towards the low-speed green-amber limit. After a short stabilization, an intermediate approach is carried out, then an ILS approach. Final configuration is Conf 3, landing gear down.
Acceleration. Stabilization. Deceleration. Stabilization. ILS on. Flaps 1. Flaps 2. Gear down. Flaps 3. Final approach.